Is the 3 by 3 matrix 1, 1, 0, 8, minus 1, 9, 1, 3, negative 2 singular or non-singular? Explain. Now remember, being non-singular means that you have a matrix inverse, and being singular means that you don't. We don't actually have to find the inverse to test this. All we have to do is to take our original matrix, 1, 1, 0, 8, minus 1, 9, 1, 3, minus 2, and row reduce it. If we can row reduce this down and get the identity at the end of our work, then this matrix would be non-singular. And if we can't do that, if we somehow manage to lose one of our pivots, then it will be singular. So that's going to be our goal. Let's first see if we can get zeros in these two positions here and here. We can get a 0 in row 2 by scaling the top row through by a negative 8 to get negative 8, negative 8, 0, and adding it to the bottom or middle row. We could also scale the top row through by a negative 1 to get negative 1, negative 1, 0, and add that to the third row. If we do that, along the middle row, we obtain 0, minus 9, 9. Along the bottom row, we obtain 0, 2, minus 2, and the top row remains unchanged. Now notice that these two rows could be scaled down. The middle row could be scaled, say, by negative 1/9, and the bottom row could be scaled by a positive 1/2. If we do that, then the middle row would become 0, 1, minus 1, and the third row would become 0, 1, minus 1, whereas the top row is 1, 1, 0. Next, let's try to get zeros in these two positions. We could get a 0 in the top position by simply subtracting the bottom row from the top row. And if we did that, we would have 1, 0, and 0 minus minus 1, with the middle row unchanged. To get the 0 in this bottom row, we could also subtract the the second row from the third row, in which case we would have 0, 0, 0. Notice that we've just killed the entire last row. There's no value here to act as a pivot. That means that this matrix, which you can see is in row echelon form, is not row reducible to the identity. So we cannot get the identity matrix. That means that our matrix is singular and has no inverse.